Welcome to C&EN Uncovered. I'm Craig Bettenhausen. C&EN Uncovered is a podcast series from Stereochemistry. In each episode, we'll take another look at a recent cover story in chemical and engineering news, and hear from C&EN reporters about striking moments from their reporting, their biggest takeaways, and what got left on the cutting room floor. In this episode, we're talking about solvent wastes, their disposal, and a new rule passed by EPA in April to regulate them. On average, from 2011 to 2021, academic labs generated around 4,300 metric tons of hazardous waste each year. And more than half of that waste ends up burned. In a pair of stories that appeared in the July 15th print issue of C&EN, today's guests looked at the consequences of the new EPA regulations and what solutions academic institutions are coming up with to accommodate. We'll put a link in the show notes to those stories. I'm here with C&EN policy reporters Krystal Vasquez and Leigh Krietsch Boerner, who wrote the articles. Hi, Krystal and Leigh.
Hi. Hello.
So starting off with Leigh, for anyone that hasn't had a chance to read the article yet, can you give a brief recap of what it's about?
My story is based on data from hazardous waste shipping reports. I wanted to find out how much solvent waste academic labs used. I wrote a story about doing organic chemistry in water last year. One of the people that is pretty prominent in that area is Bruce Lipschitz. He's at UC Santa Barbara. He said to me at one point that what kind of got him going on trying to get away from using organic solvents was that he made so much waste that basically his environmental health and safety guy at UC Santa Barbara was like, you are the biggest hazardous waste producer in the whole county. And so he was like, oh, shoot, I better stop that. But then that made me think, well, how much was he making? And then how much do labs make? And so this story is me trying to figure out the answer to that question. I gathered publicly available government data and analyzed it to find out what kind of waste academic labs were making and what happened to it, basically. What I found was most of the waste that comes out of academic labs is solvent, and most of that waste does end up burned. So some of it ends up in an incinerator that just burns it and it goes up into the air. But some of it also ends up being used as fuel for cement kilns. So it's also burned, but then it's used to actually power the cement kiln. So that is different than an incinerator.
So an incinerator is burning it just to get rid of it.
Yep.
Whereas a cement kiln or another cogeneration plant is both getting rid of it, but also using it as fuel.
Right. And I wouldn't say getting rid of it. It's just changing form, right?
Well, that's true, yeah. So in the article, you showed that the amount of annual waste generated by these academic institutions, which was more than 4,300 metric tons, is nearly equal to the weight of 7 fully loaded Airbus A380 aircrafts.
Yep.
How is that even possible? I know I used a lot of solvent when I was in the lab, but that just seems like so much.
Well, there are a lot of academic labs in the United States, and we did just look in the United States. So we don't have, at least I didn't have for this article, data from, Europe, South America, China, other places in the world. So it's just that. But some labs use a lot of waste. Can you think of, your regular old organic chemistry, synthetic organic chemistry lab, even if it's like on the small side, maybe you have 10 graduate students and you have a few postdocs and maybe a scientist or two. How often are those people running columns? That's what a lot of the solvent comes from, but it also comes from, running reactions and things like that. And then, you rotovap it off and you put it in your solvent waste container and then you take it down to EH&S whenever they collect it and then it kind of disappears. But as far as you're concerned, it disappears.
Yeah.
As far as the atmosphere goes, it does not disappear.
So one of the big solvents in a lot of organic labs is also one that's recently come under some specific EPA scrutiny. Krystal, I think you're going to be the expert on this. Tell us about your part of the cover package.
So my story focuses on recent EPA regulation that was finalized at the end of April of this year. And basically, the EPA banned most uses of methylene chloride, which is more commonly known as dichloromethane in labs. The EPA is requiring them to do this workplace chemical safety protection plan. One of the big things that academic labs and EH&S professionals were saying in public comments before this was finalized, that this would create a lot of havoc and a lot of extra work for them and might end up affecting the use of DCM or dichloromethane or methylene chloride in the labs. Overall, I think larger universities are going to be less affected. The problem comes when you look at smaller universities that have limited staff and limited financial resources and will probably have to outsource a lot of this exposure monitoring. And so a lot of the people I talked to from those schools were saying that they will likely have to get rid of DCM in their labs. It's a big unfolding story.
So one thing I want to understand a little bit, these changes from EPA, are they changes in how people are handling the solvents, or is it mostly a change in paperwork?
I would say that it leans towards a change in paperwork. For research labs specifically, it's requiring basically a plan to talk about what you would do in case of exposure. They're setting new exposure limits. You need to set up a regulated area. And so you need to talk about that in your documentation. Again, the biggest thing is the exposure monitoring, which is also technically on the side of paperwork, but it does require actual labor from the researchers and EH&S staff to actually get that set up.
And, from EPA, is the big concern here environmental impact or human health exposure?
The main thing that the EPA is focusing is the human health impact. So DCM has a lot of health effects. It's a carcinogen, and it has caused the death of people who have used it, typically for consumer use, but it does have that potential health effect. So they're hoping that with these new protection programs that the EPA is setting up, that it will reduce the likelihood of those things happening, but it does have consequences in terms of actually setting up those plans and making sure that it doesn't necessarily interfere with the research.
So I have a very personal interest in this because when I was in the lab, I was the person who was in charge of going down to the central room and refilling drums from a giant drum. And for me, that was literally sitting on top of a 55-gallon drum of dichloromethane, pumping it into a smaller bottle. How dangerous is dichloromethane exposure? I think for a lot of chemists in our audience, they've been exposed to a lot.
I think that if you're using it the way you're supposed to, in a fume hood with the right PPE and all of that, your exposure should be smaller than if you were, saying, using methylene chloride for a paint thinner. It used to be in paint thinners until not too long ago. I don't know how to answer that exactly, but I do think that academic labs and research labs in general are very unique places that have a lot of different control methods and a lot of safety protocols set up. So yeah, I would say that if you're following your chemical hygiene plan that an EH&S person has set out with their expertise, that you should be fine. I think that what the EPA wants is just to lower those exposure limits so that you're just even safer,
I would say that it's really, really difficult to figure out an individual's risk from that, just because of what Krystal was saying, how are you using it? Is your hood on? How much are you using it? Blah, blah, blah. For me, when I was in graduate school, dichloromethane was one of the few things that my molecules would go into because I made kind of big molecules and sometimes they had metals in them. And so I went through a ton of dichloromethane, and it was the same for a lot of people in my lab. I can't imagine not being able to use dichloromethane. It would have really messed up my research personally.
One source I talked to said it's basically a whole paper's worth of research to try and find a different solvent for a reaction. So this is going to take hours and hours and hours of work for these researchers who are either voluntarily choosing to get rid of DCM from their labs or are being forced to by the circumstances of their institution.
And dichloromethane is kind of a superstar solvent in some labs, but it's just one of several solvents. And Leigh, your story looked at a much larger category of solvents. In a chemistry lab, it feels like you go through a ton, literally hauling these things in and out of the lab by the drum. But how do the volumes used in research labs compare with the volumes used in industrial applications? And is it for the same kinds of uses?
Well, an industrial lab and an academic research lab are very, very different places. I will say that just for my own sake, I was curious about, all right, so, we figured out, this hazardous waste that's coming out of academic labs. How does it compare to the entire amount of waste, from a particular year? And it was very, very small. It was 0.005% in 2021.
Okay.
So that is like, I don't know, what's smaller than a drop in the bucket? A nano drop in a mega bucket. So it is a tiny, tiny amount. But what the important part is, according to Adelina Vuchkova, who is the director of the ACS Green Chemistry Institute, when I told her the numbers, she was like, okay, wow. But then she also said, well, what's important here is teaching graduate students how to sub in different solvents. So it's not necessarily the total amount that academic labs are making. It is the learning process that students are going through because, when those students graduate, when they leave, they're going to industry, they're going to teach their own academic lab, they're going on to other places. And many people hope, including a lot of people in industry, that they will take this kind of knowledge with them and then apply it later on.
I guess there's industrial labs and there's also like industrial scale synthesis.
Yes, what I'm speaking of is industrial scale synthesis, not necessarily like a research lab, but, the part that actually starts making the drugs and scales these reactions up, huge, huge amounts when they have to make huge, huge amounts of drugs, right? And so that's where the volume comes in. With halogenated solvents, what is the fate of some of this waste? 28.32% is incinerated. 18.97% is used for fuel blending. That means that it's used to basically power a cement kiln. And 45.83% is bulked.
Yeah, I saw the word bulked in your story, and I read it a couple times, and still, it's a strange phrase. It seems like it's an ambiguous term all by itself.
Yeah, it's completely ambiguous because what does that mean? It basically means that companies that deal with the hazardous waste, they take waste from different sources. So that means that this school gave this here, that one across town made this much. They basically combine it and put it in a bigger bucket, say like a tanker car or something like that. As far as what I've been looking at, which is the Resource Conservation and Recovery Act data, RCRA, RCRA is what they call it. According to the RCRA manifests, that's kind of the end of the road as far as what you can see. But that goes on to be either incinerated or used for fuel blending or et cetera, somewhere else. So that means that as far as my analysis of this data goes, what's being burned, either incinerated or as fuel, is more than what I'm able to pull out.
So, Krystal, the EPA banned a lot of uses of dichloromethane a few years ago. Paint strippers is the example that a lot of people know of and that we covered. How does this new ban differ from the older ban?
Yeah, so the initial ban was just paint strippers, I believe, commercial use paint strippers. This time, they've kind of made it more comprehensive. So they've banned all consumer uses of DCM and most commercial and industrial uses of DCM, with the exception of, I believe, 30, which includes using it as a laboratory chemical.
And this isn't even the first time that we've taken some solvents, specific solvents, out of organic chemistry labs, right? That isn't your story. There's some other previous solvents that used to be used a lot and now they're not, right?
Right. Benzene is, I believe, one of the biggest examples and one that I heard about repeatedly. Benzene used to be ubiquitous in the lab and now it's not used as widely anymore. So I think the general consensus that I reached in my story was that it is possible to reduce the use of DCM despite how popular it is right now. I think it's just going to take a lot of work and a lot of rethinking of reactions and rethinking what your chemistry needs and also rethinking the different hazards that you have to balance out as you're deciding which solvents to use in your chemistry.
So reducing solvent waste is a big part of green chemistry. It's in more than one of the original 12 principles of green chemistry, which was published about 25 years ago. This far into that movement, how much progress has been made and what's coming down the pike as far as, new approaches to these solvents?
There are other solvents that you can use that are a little bit more eco-friendly, like I don't know, one called the universal solvent, water. It is difficult to use water for some types of reactions, but, there's a lot of research going on into doing chemistry in water. There has also been a lot of research into what makes a more environmentally friendly solvent. GCI has actually a guide on replacing your solvents with greener alternatives. There's a lot of research into going, okay, I need a solvent that does X. Look at this table. Okay, these types of solvents do X. Maybe I can use one of those instead. So that's kind of where it is.
I think one thing that's important to point out is regardless of whether you're replacing a solvent because of regulation or to try and get a greener solvent, you have to really think about the potential health effects and the safety issues that come with it. So one thing that I found in my story that some people are concerned about is that in order to replace DCM, they might end up replacing it with a solvent that has different hazards. So maybe it could cause lab explosions, or maybe it's another solvent or another compound that might be on EPA's list. So I think that's just something to keep in mind as people are doing their lit searches, is to really do their homework and make sure that they're not replacing one solvent with something that could be worse in another way,
Yeah, the old regrettable substitution problem. So is there anything else in either or both of your stories as you worked on this that you thought was really interesting and just didn't make it into the written piece?
One thing that came up a few times and I didn't get to include it was the worry that dichloromethane is going to get more expensive because of this regulation, because the manufacturers are also, they have to comply with this regulation as well. And so I haven't looked into where DCM is produced or like how much of it is US based, but I think there was definitely concern amongst academics talking about like, is this going to cost me more? And if I'm at a small school, will I be able to afford it, regardless of if we can set up the monitoring program and do all the other things with the workplace chemical protection program?
Something else, Krystal, that I wondered about too is, okay, you say maybe small schools just might have to say, okay, we just can't use it because we can't keep up. We can't, have somebody dedicated to just like figuring out these regulations. Is that going to affect the recruitment for professors? So you think, professors like uses a lot of DCM for their research. I'm not going to go work at this school. They say I can't use DCM. I'm going to go work at this other school.
I couldn't really gather how much of an impact it would have like on student recruitment. I think that when you work at a primarily undergraduate institution or other liberal arts schools, that you are competing with bigger schools in general. So that competition is always going to be there. So I don't necessarily know if this is going to add to it, but it could be just another factor of like, if someone wants to do a very specific type of chemistry that needs DCM, they might end up going to another school.
So Leigh, what about you?
I have a whole section of data that did not make it into the story. And that is on specific schools.
Ooh, are we going to get in? We're going to name names?
One thing you'd have to remember is the bigger the school, the more students it has, the more waste it's going to make. Mm-hmm. If you're talking about, academic lab research. Just for instance, in 2021, the biggest producer of hazardous waste was the University of California, San Diego. And that was 142.35 metric tons. And then the next one on the list is the University of Michigan at around 100 tons. So that's a pretty big jump. But the other kind of interesting thing about this data is that sometimes the same schools are at the top, and then one year it won't appear in the top 20 at all.
Well, Krystal and Leigh, thanks for diving deep on this with us. There's a lot here, and I enjoyed reading the stories and enjoyed talking with you about it.
Thanks a lot, Craig.
Yeah, thanks.
So people can find me on social media as @CraigofWaffles in most places. Where can they find you all?
I am on Twitter or X or whatever it formerly known, that thing, @Leigh JK Boerner. I am on Mastodon. I don't remember what the heck it is. You can find me on LinkedIn, but I'm never there. Birds, homing pigeons will find me. You just have to know what kind of treats to give them. But I do have cats. They might not come back.
I am occasionally on Twitter /X @CaffeinatedChris. The last part spelled KRYS. And I am on Blue Sky at K Vasquez. You can find me there.
Well, you can find Krystal and Leigh's cover stories about solvent wastes and the EPA's updated regulations around methylene chloride on C&EN's website or in the July 15th print issue of C&EN. We put links in the show notes along with the episode credits. We'd love to know what you think of C&EN Uncovered. You can share your feedback with us by emailing cenfeedback@acs.org. This has been C&EN Uncovered, a series from C&EN Stereochemistry. Stereochemistry is the official podcast of Chemical and Engineering News. Chemical and Engineering News is an independent news outlet published by the American Chemical Society. Thanks for listening.